Hello, everybody. Welcome to the stream. We're gonna do the stream today. Did you like that YouTuber intro? We did it. We did a YouTuber intro. Hey, look, recursion. That's always fun. Okay, we are live. I didn't check if you can hear me, but I'm just gonna assume you can. No plan today. I kind of want to make a compiler, so we're gonna do that. So let's just, I guess, start. I'm not creative. I just want to call it compiler. Let's say, we're gonna call it the fun compiler. Okay. Let's start up Emacs. Wonderful. How's everybody doing today? Hey, look, I almost forgot too. Let's make the announcement on Discord that I am live. The red circle. Live. You know where? Twitch.tv/lens_r. Working on not light. We're going to be making a compiler for fun. Sure. We're officially live. Hello, everybody. Welcome, welcome. Prima. All right. I'd say let's get a little bit of a README going so that I don't forget what I'm doing. We're loading org mode now, I believe. Yep, there we go. Do I have something, yeah snippet, like file header? I do. I'm actually not gonna have a title or an author. It's me. Or description. I just want the created, actually. I'll just go with one of these headings. So this is going to be the fun compiler. We know that. I don't really have a plan. I just want to make a compiler. It sounds fun. I think that describes the mood I'm in right now. Let's just go ahead and make myself a little bit of a helper as well. We're gonna make to-do. And this is gonna say, let's see, we're gonna have to first parse, well, Lex source into tokens, right? Then we're going to have to into tokens or something into a data structure that describes what the tokens need to describe. So we can Lex parse tokens or something into AST, just a tree containing data about the program. Perfect. That's good enough for me. And then we're going to need to compile AST into assembly. Let's start with x86-64. We could also transpile into another language that then gets compiled, like C or something. There's a lot of or somethings in here, but I think that's fine. So, uncompiler to do. Yeah, I like that. Okay. We have to choose a language now. What language should we write this compiler in? That's kind of important. I kind of vote for C or C++, but I'm a systems programmer. I kind of always will. Maybe that's not a bad idea. I think that's the way we'll go. We could also go something like Python or something like high level, more of a scripting language, but that would really just be to bootstrap until we can self-host, and I don't really have plans like that, so I don't know. Let's just dig into it. I guess we have to write our first example. So what does our source code look like? Well, there should probably be an entry point, is what I would guess. So let's think about a use case for this language. Maybe the fun compiler, it should at least, we know it should be able to do math eventually, but I also want to be able to print strings. That would also be cool. And also alter strings and print buffer, maybe like arrays or buffers. I'm getting ahead of myself. Let's think about what we need to do. We need to write a program which then somehow is able to be run, which means we can go down to assembly and then use like GNU as to compile that. Or we could use NASM if we want to go the Intel route. We could go with C and just kind of make very high level calls. Because if we make it transpile into C, you could kind of do anything you can do in C, which is anything you can do with the hardware, right? And you have the whole standard library of the OS, which is kind of cool. And in assembly, you can also do the same thing. You just have to set up the parameters to the C functions before you call them, which kind of sucks, but it's not too bad. So we could transpile the C with the eventual goal of compiling into assembly. I mean, eventually we want to compile down to native machine code, but I don't think we need to think about that yet. So our source code, I don't know. I think this is fine. Have a beginning and end. And then we should have comments, obviously, but I'm not going to do comments yet. So I think I'm going to do like a Pascal type structure where we have, you declare like a program, right? And then it'll have a beginning and an end. And this is kind of the entry point. And in this space here, you can define functions and variables and stuff eventually. That would make every program look very similar. And I don't know if this is necessarily the syntax I want. So let's think about, what if we did something like this, huh? And then things could go up here. Well, then we don't know the name of the entry point, so that kind of doesn't work. So we have to do like main. This is starting to look a lot like C now. So if we have main, but then that would be required in every program. So I kind of want it to be like a scripting language like Python, where everything at the top level is just executed when the file is run. But I also want there to be functions, which is an interesting one. Because if we have like, let's just say we use defun, we can use anything. So if we define a function of like foo. Let's just say we do the classic like C syntax. But it could return. So is there a better... I guess we could use this double operator as the return operator for functions. That should be fine. But if it returns a type, let's say an integer, right? I think that's understandable because we define foo, which takes in an integer. But then how do type names happen in here? Is it the same thing? Like, would we have A, which is an integer? B, which is an integer? That's kind of cumbersome. I feel like that's a lot. You could use the colon, which is like the classic type coalescing parameter or whatever. Type coalescing operator. I kind of like that. So defining a variable at the high level, we're going to start with an unknown symbol. That kind of sucks. Then we're going to have a type, a known type, a type that must be known, or we generate a compiler error. And then, ooh, you know what? We're going to steal this. I think I saw this. We're going to get inspired by another language I've seen online. I think it's called Jai, like J-A-I. It's for making games. It's not available yet to the public. But you can, the assignment operator, like in math, when you assign, this is the assignment operator to reassign a new value to an existing variable or something. But we could also use this as a declaration, where the declaration just has this in the middle, and then we could have that. Or, so then, okay. So a declaration would just have something in between the colon and the equals. And then a reassignment, the colon and the equals just bunch up next to each other because the type is already known. I kind of like that. I like that. So then when we're compiling, we're going to get to a symbol. Also, I keep putting semicolons, but I don't think... Do we necessarily need them? I guess we could just go new line separated, but allow for like backslashes. So like if you want, you could put a backslash new line. You could put one here, and they're just ignored by the compiler. And then we could treat new line normally as an expression ender, a terminating operator, I guess, or something, an expression terminator? I don't even know what to call a new line in that case. But that would be more like Python. This is interesting. I kind of like this syntax. We've developed something that I'm not unhappy with. So we have A, which is an integer. We assign it to 0. Hopefully we can do something to it, like eventually print A or something. Maybe we do something like that. I don't know. So I kind of like the idea of not using parentheses for parameters. I don't know why. But what if we print A, B? See, that would be hard to read if you then called, like, how do you separate calling a method? Okay. I think we're going to stick with the parentheses for function calls, if we even get there. Because for now, Here, we can leave all of that. That's fine. Now we need to actually write the everything, right? We've done the easy part in having the ideas, so now we just need to actually begin. So it sounds fun. There's an example of some code that should be valid and able to be compiled in example. Cool. Let's start with main.c, right? We may want to start a CMake lists as well. Oh man, I don't remember really how to do this. I know we need a project call. We need CMake minimum required. Oh hey, I didn't know I had like language server. Oh hey, this is nice. At the bottom I'm getting completions. So I put in version. Okay, so probably like 3.14, that's what they use on Debian. Pretty old. What do we put in project? Project name, language name. Okay, that's pretty easy. This is the fun compiler in C. I believe there's some stuff I can steal from Light. That would be useful, like C cache. Yeah, that's worth it. And yeah, sure, why not? So exporting a compilation database, the compile commands, allows language servers like IDEs to be able to read your includes and stuff from CMake. It's very nice. So that's light graphics. You can also say version and languages. I don't think we need that. Whoops. Now we can just add executable. What should we call it? Should it be fun compiler? The fun compiler? FC? I kind of like funk. We're going with funk. Okay, now that we have funk, we're going to need to, yeah, include a whole bunch of stuff. So for now, we should just have main.c. Also, it's not a bad idea to put this in source. I think I'm going to do that. Then we can save this, create the directory. Perfect. Okay, so we now hopefully should be able to, this should work. We just need to have int main void return 0, like the most basic of C programs. And now, we check it out. Okay, what do we need to do? Probably just go here. Yeah, sure. 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 I think that's fine. Called with unknown argument 3.14. Okay, so I screwed the CMake minimum required up, but it still worked. What a legend. Do I have to put version? That's probably what I screwed up. Yeah. That's fine. Cool. Okay, now, make sure we do that again. We should just be able to build the build. And look at that. We now run. And if we echo the last exit code, we return 0. Hopefully this works. Let's try and return 420. So now we just need to recompile. run it again, and echo the last exit code. And hey, it worked. We're compiling C with CMake. Wonderful stuff. Now, we just need to figure out how to, you know, create a whole compiler. I think we can do it. Okay. So, first of all, we need to accept some arguments. That's kind of important in compilers. They have compiler flags. And argc is less than 2, then we should say print usage or whatever. And yeah, we're gonna need stdio. And we're gonna have to say, we should no return this or whatever, but we're just gonna do this. Usage. Hey, could we get argv? Wonderful. And yeah, we'll just take argv. We can just do this. And then we can say path to file to compile. Wonderful. I think that's understandable. Eventually it will be much more complicated, but that's good enough for now. Then we just have to provide argv at 0. And by dereferencing this array, or this pointer, because arrays in C are just pointers. By dereferencing this pointer, we get a pointer to a character, which means that this should be able to print the string that's there. And we should always get argv at 0, because that's actually the program being run. Wonderful. So now, we try and do the same thing. /func. Now, we get a usage. Includes standard lib for exit. Okay. That's fair. And look, we get our usage out because we didn't provide a file to compile. That works great. So now we're gonna need a file's contents, right? So I think we'll just get that as a heap allocated buffer of bytes. Does that sound right? We could also like incrementally read from a file as we lex and parse it, but I don't think I want to do anything like that. I think we can just deal with an entire file at once, especially at the beginning. So we're just going to get a file's contents, and we're going to need a path. And effectively, we just need to open the file at path for reading. We need to get the file size, right? So we're going to need file size. We're also going to say if not file, could not open file. At blur. Okay, wonderful. Then return null. Otherwise, we should get the size. Can't really do that. So I'm just going to call it size. And, excuse me, to get a file's size, we're going to use ftell along with fseek or fgetpos. Let's look them up, because I don't exactly remember. That's a good one. So fgetpos stands for file get position, and you can get the current position in a file stream from C. And it returns an fpos t, not a size t. That's fine with me. And it just requires a pointer, and it returns 0 on success. So we should kind of do something like this. Do some protection there so that we don't always hit this assert. We just want to do it if this does not equal 0. Not get file position. I guess file. Yeah, that's good enough. And it also needed an fpos t pointer, so this is going to be just our result. Okay. So now this call should get the position into out set pause. See, they don't even handle their example doesn't even handle the error. That's hilarious. In either case, we're just going to continue. It's fset pause. They also set error now. Okay. So how about we do this? If it does not succeed, we're going to say could not get file position. We'll just say get pause failed. What is error no? How do we print out error no? Anybody know? Is it just an integer? We'll go with that. We'll go with an integer. We'll say fgetPos failed for some reason. Turn 0. We could just crash the program, but I don't think that's necessary. And I think that's how that would work. It still needs a pointer, okay. Passing numbers around by pointer is kind of odd. I don't really like doing it. But whatever. Set pause and get pause. So now in between these two, I can do whatever I want seek-wise, and it will be restored. So now I need to seek and tell. Ooh. That sounds promiscuous. I'm gonna seek and tell. So this is how we use tell. Just say out equals that. So this is, we're gonna rename this to original. Okay, Eglet, could you connect please? Thank you. Original. Perfect. Now we're gonna have an fpos_d out. So we need to seek to the beginning of a file. Seek set. Then we can seek to the end. And what does this return? Size t? It returns an int, so I have a feeling I did this wrong. I just need to seek to the end, then I can ftell to get the byte offset. That's right. And it returns a long int? Question mark? That's kind of confusing. So the file size itself is a long. That's fine. And that's out. I think that's fine. We can now get a file size. That's important. Whew, a little bit of a distraction there. That's important because now we should be able to make a buffer in the correct size. And this will use malloc. And we're going to just malloc the file size plus 1. We're going to say contents at size equals a null terminator. So this ensures that we have a string, effectively, a string of bytes that refers to our file contents. Wonderful. We then just need to read into the buffer, let's say 1 byte at a time, file size amount of bytes from file. Wonderful. So we read into contents this many bytes. That seems fine. Now, so content should contain the contents of the file now. We should say like size t byte spread or something equals freed. We're going to call it element spread in case we change it from bytes. Element spread. Well, we'll call it bytes because we're comparing it to bytes. Byte spread does not equal size. Return null after freeing contents. Otherwise, we read all the bytes we needed. We should probably do this in like a different way to handle large files, but it does not matter right now. We are just starting up. So let's see if we can print the file's contents. Contents of blah. We'll do a new line, dash, 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 new line. We'll do a new line, dash, 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 new line. We'll put it in quotes too, why not? Then we just need to give the path should equal argv at 1, right? Based on our given arguments. And then we have our contents. And our contents is going to be equal to the file contents at path. Look at that. We can then free our contents, and that should be us on our merry way. Hopefully, we can go build this. Let's make this a little bit bigger. Okay, it builds and it runs. Okay, we got null. Why did it return null? Bytes read did not equal size. Alrighty. Sure. Sure. So bytes read plus equals however much we read, and this should be size minus the bytes read already. So try and read the rest of the file. But read it into the right iterator. Okay. This is terrible naming, but it's fine. Snake case was made for this. I guess this can be here. Okay, that's fine. So now we increment our right iterator into our buffer, however many bytes we read, which means next time around. And while it's less than size, I can't see this going wrong. Perfect. Yeah. See, didn't go wrong at all. Looks great. Something went very wrong. So it's just spinning the CPU, probably in that while loop we just made. While bytes read is less than size. So size minus bytes read should keep getting smaller, but if we read 0, that would also not be cool. We're just going to do that. If we read 0 bytes, break out of the loop. Hey, look, it ran. Didn't work, but it ran. So do I have to -1? Am I doing an off by 1 error? I don't think so. Let's see. We get a file size. We have the amount of bytes that we've read so far. fread definitely returns how many bytes it read. We're reading 1 byte at a time. Size minus bytes read, so that should be fine because we have size here. If it equals 0, break, and that's what we're doing. So why would fread return 0? Right? That's what we gotta go look at. fread. Thank you. If this number differs from the count parameter, either a reading error occurred or the end of file was reached while reading. In both cases, the proper indicator is set, which can be checked with ferror and feof, respectively. Okay. Like this. Error while reading. Like that. If feof, well, if we made it to the end of the file, just break. There's not really a complicated sequence of actions that needs to be done there. And that, it says, should handle it, and we no longer need to handle differing counts. It does just exit right away. So here's the issue. We never add bytes read. So this should happen here. Okay. Kind of confusing, but I can live with it. The idea is if there's an error, it's a big deal and we should probably return null and stuff. But if it's the end of the file, it's kind of just, that's how things work. Hello, which language is this compiler for? What's up, Angel? How's it going? I don't know. I kind of just woke up this morning and wanted to write a compiler. So here, I have an example. We came up with this on stream. This is kind of what it's going to look like. It's going to be statically typed and compiled, obviously. So we're either going to transpile into C at first. You are making your own language. Yep, yet another time I am making my own language. But yeah, I just woke up this morning and I wanted to do it, so we started. And we're getting there. We're just about getting to reading files. We're just not quite there yet. So if this is the case, printf read. This is probably a long. How do I print a long? I don't remember how to print a long. Now can it compile some code? It will, my guy. It can't now. Can you fix it? It's LD. Okay. I didn't remember that. Right now we are just at the stage of parsing arguments, getting a file path, and reading its contents. So if this here happens, see, this here happens. So we get to the end of the file, which means that we don't properly get the amount of bytes that were read. So again, if I do a -1 thing, we still get here in the same error. So when we reach the end of the file, it's different than when we seeked the end of the file. It's a little odd. What's the trick of an executable file? Is there a Windows library for it? Oh boy. No. No. There's no tricks to an executable file. So if you look, there's like the executable and linkable format. which is a common one. And if you take a look at it, it's complicated. Is there any magic numbers? Of course there's magic numbers. That's how every file type works in existence. See? Here's elf. This is what they use on Linux. It's an open source format, basically. And you can just write a parser and a generator for these structures. And then you just write them to a file, and the things that can run these executables, they work. All these, right? That's how Lexer OS runs executables. It uses the executable and linkable format, which is very nice. It's open source, allows for all sorts of different types of code. You are amazing. Thank you, my guy. I'm not. I promise. I'm not amazing. So if we look at executable file formats, you can see that there are quite a few, right? But only a few of them, as you can see, run on Windows. They're PE and PE32+. Now, almost nobody in the world, except for Microsoft, one, is allowed to make compilers that generate these, and two, is willing to. Because if you looked at the ELF, it was rather simple. This is just ridiculous, and this is just the header. This is just the header. Like, that's just the beginning of the file. And then you have more stuff. So nobody generates compilers that makes portable executable format, because Microsoft just kind of sucks. Like, look how many even file name extensions are accepted. It's terrible. And it's not open source. Technically, it's like behind a license, and you're not technically allowed to do it. But here's the thing. You can take an ELF executable and convert it into a PE executable. And that's actually how most compilers work nowadays. And you can just use like object dump and read ELF is all you need. And you can make a portable executable, a very basic one. This is not what we're going to be doing yet. This is what we would be doing if we make this compiler very, very mature. For now, there are already programs that compile executables, right? So we can compile this C program into an executable, for example. So once we parse our language, we can just write to a file C code that does the same thing as the code that we are parsing and compiling, right? So then we compile our code into C code, and then the C code can get compiled into machine code into the executable by an external compiler, any compiler. But that will allow us hopefully to get started rather quickly. And then we can move down to assembly, like we can generate net-wide assembly, or we could really, if we wanted to generate WebAssembly, we could generate x86 64 assembly for AMD and Intel. We could do like external calls. We just need to know which OS we're compiling for. But yeah, I'd say that's like where we're going to start. We're going to start either with C or assembly and compiling into that. That way we don't have to do all the work of all this. Does compiler convert to assembly? So a compiler technically just takes a program and transforms it into something more low level. Like a compiler could take C# and turn it into C code, and that's technically a compiler. It's just a transpiler is what it would technically be called. A compiler can convert to assembly, or directly to machine code. It can do either. Most architectures, like how people build compilers, is they make a compiler that generates assembly, Then they make an assembler that generates machine code from the assembly. Because things are complicated and splitting them up into smaller little tasks helps brains comprehend them. What about your compiler? I don't know. I started this morning, and we literally, if we take a look at the README, I don't really have a plan. I just want to make a compiler. It sounds fun, right? So we're just we're going for it. Whatever we write and ends up working, that's how it will be. It sounds so fun. You can't tell if you're being sarcastic. So we get to the end of the file. This is an interesting one. Why is this happening? What if I did that? No, that's not going to work because we get to 70. I'm just going to do this. What do you want to be? Long? Long. Reading 76 bytes. Okay. And then you read 70. What? Okay, so we tell fread to read 76 bytes. And it gives us 70. Which some would say is confusing, because we should just get the entire file. So maybe we just have to say, not this. Just accept that we may end without an error happening, and hopefully F error catches everything. Well, that's worrying. Excuse me. Though that's not at the end of this file. That's worrying. Why? What? So this is quite confusing. Oh man. This doesn't make any sense. I must be doing something wrong. Oh, I know what it is now. Do you see the error? Why do we keep getting stuff that doesn't make sense and looks like it's part of probably another program? Yeah, see, it keeps changing. It's probably that's probably my environment actually for this program. My path. Why changing, right? It's the same thing where it's the same program and it just changes. Ooh, it's wind. Is it gonna change? Oh, it's not gonna change now. So now there's some other program using that memory for that right there. On the heap, most likely. Basically, of course it doesn't change. It'll never change now. It'll forever be wind. What's happening is, how do strings work in C? You have a string, you can, right? This is a string. But how does it actually get printed when you do this? Some string, right? It gets printed by printf by looping over the bytes and assigning it to a character. So when you loop over the string, you then say string ++ at the end. So this will increment the memory address, and then you'll get the byte at each memory address as you go. And they basically just say put char C, the character that's at this memory address, until, since it's a while, until this evaluates to 0. And the character that evaluates to 0 is inserted at the end of every string in C. And it's this character, the /0. That's the escaped sequence. And this 0 byte allows loops like this to work, right? So if loops like that aren't working, it most likely has to do with this 0 byte. And remember how we weren't reading the full amount, the full size of the file? We're only reading 70 bytes, right? But then we put this at the end of the file buffer, which isn't correct. So we have to actually put it at bytes read, because that's how many bytes we've read, and at the end of that we want no more. So we put a /0. Now, look at that. Beautiful stuff. Completely fixed. We now get a file's contents. Wonderful. So, now that we have a file's contents, what do we need to do with it, right? We need to, does anybody know what the first stage of a compiler is called? The name of this function, what should it be? Also, let's create an error while we're at it. Okay, and an error will probably just have like a message for now. And enum or type. Now can we parse it? Nice. You're very close. I think that should be enough to start us off with. Okay, so we have a basic error. But first, before parsing, we need to lex. And lexing actually splits the input, our example. It'll split it where it needs to be split effectively. So we need to get a string that is A, right? Because we need to operate on the variable A. We need to have this. Lexer parser. Yay, you got it now. We need to lex. So first we need to lex. We'll return an error. We're going to need an error syntax. And we're going to just call it lex. We're going to do it a bit weird. I think this should be fine. We're going to need some results, right? I think that should work. I may have to take a look at how I've written Lexers in the past. It's been a while. All right, so first of all, let's define, I guess we can do a error. Okay. Something like that. That should work, right? Oh, I need to probably name this. There we go. That's better. And then this will just say define to do. Let's see. We'll do that by hand. Does Lexer pass the spaces? Yeah. It's depending on how your language works. Yeah. I think ours is going to be white space agnostic. Like, it doesn't matter if there's 20 spaces here or none. We're going to try. But the problem is we're going to have to treat new lines not as white space, but as a delimiter. Otherwise, we're going to need like semicolons or something to delimit expressions or statements. That's going to be a whole thing. So let's say we lex into a string. Is this correct? I don't think that's correct. I think I need to have like this. Yeah. Okay. So we're going to take in a string and we're going to set these two to the beginning and end of the corresponding, the next token. I think that is understandable. Let's go check how I did it in Light, because I am just wanting to make sure. I don't even know where I did this. I think I did it within the parser. Because Lisp is, there's basically no lexing that needs to be done. Okay, hopefully Emacs didn't crash. We're getting a little hang up here. Hello? Hello? It's not happening. Emacs? It's gone. Well, that's unfortunate. I think Emacs just crashed. We're just gonna see if we can open a new one. Nope, we can't open a new one. It's not letting us, so we're just gonna end this task. Woo! Now open a new one. Gotta love it. Wonder why it crashed. See what it does this time. Hey, it worked. Yeah, perfect. This will help us a lot. That's exactly what I thought it should do. So we are given a source, and then get the next token and point to it with beginning and end. I think that's... Ooh, geez. We are getting real slow today. Streama. Fun compiler. Source main. I don't really want to split this into multiple files yet. Did we... Okay, so what is it? Maybe it's... I can't open two in a row? Let me see if I can close like a clang D and if this gets solved. Are we hanging in clang? Ah, I see. It's a Microsoft thing, as usual. All right, Lex. Basically, we need a source. We're going to need another error type. And then we should probably have like make error. Let's have like error create. That way it starts with error. And this is just going to say name type message. Error name equals type message. Yes. I don't need. I keep. Okay, so I want a semicolon within this. Yeah. Wait, no, I don't, because there's going to be a semicolon after the function call, which I think they count. So now if I say can't say return error create, but I can say error prep. And I basically just remove that. It's gonna make that a little more understandable. So now I should be able to do something like this. Nearly. Expected expression. Sure, expand the macro. I see. So we can't return that. We have to prep and then return. Like this. Are you happy now? Not Lex empty input. What are you mad about? Expected expression. Expected expression. No? Okay, not semicolons, just curious. Name type message. So we have error. So it should say error equals type message. So maybe that can't happen. And message equals message. All right. What's the issue here? Expected identifier. Okay. Can I do something like that? Let's do the same thing here. No? Okay. Why are you mad? Expected identifier. So name.type, name.message. Is it these? Well, that should be fine. Error prep. Name type message. I don't know. Does anybody know about C macros and why this isn't working? I'm sure I'm just being dumb. Is it that? It's probably this being named the same thing. It is. Look at that. Okay, we solved it. So now we can do this thing. So our error, we can now create a little same thing again. And we are just going to print error. Switch on error.type. Paste. If error.type equals none, there is no error to print. What does backslashes doing? Great question. So in C, definition of preprocessor definition is only supposed to be one line. It ends at a new line. So when you put a backslash in front of the new line, it actually allows the next line to be treated as part of the last line. So this backslash allows this code here to be part of this function like macro definition. Same here. So it just continues a singular line in C. You can do the same thing within strings to get multi-line strings. It's very nice. Awesome, got it. Nice. We did it. unknown error type. Kind of nothing we can do about that. Okay, case error to do, sure. Do something like that. Error syntax. We're just going to say invalid syntax. Whoops. It's a little better. What else do we have? Error type. Mismatch types, sure. What else do we got? Error generic. It's just gonna do nothing. Put this at the top then. Well, we'll put both of the things that do nothing at the bottom. Okay, then there's one more. Error arguments. And this will be invalid arguments. Perfect. I think that's good enough for that. We can put a new line and then say if error.message print the message like that. I think that would work. We can test if that works by saying error equals lex null. And these don't matter either. And we can say print error. Perfect. Error, invalid arguments, cannot lex empty source. That, we can make this look a little better. That's like 5 in. Oops. Let's try that. That's much better. Invalid arguments cannot lex empty source. We can print errors now, yay. So now we need source, which is actually going to be contents. Beginning, end. All right, and this is actually getting into parsing. So let's just make that a thing. And get something like that. You want to learn C? You can do it, my guy. I believe in you. It is completely possible for you to learn C. It's been around for 50 years. But where? In your own head, I would recommend, is where you learn things, like in your brain, if you can memorize them or remember things. I'm just messing with you, but I'm also not. You just have to start. Like you're learning right now, right? You could go write some C code and have an idea of what's happening and what you're writing. You're not just copy and pasting. But you just have to start and try and write something. What's something you want to make? Why do you want to get into programming? What do you want to make in C? Because I have that same issue where it's like, well, I want to code, but I have no idea what to code. So we can now parse expression source contents. And for now, let's say error, it's that, print error. Can you learn a language by writing? Absolutely. So if you see what I do, all you have to do is learn like, okay, how do I declare a variable? What can I do with variables? And what do I want to do, right? Because I know pretty high level like what I want to do. I want to open files, take their contents, read them, and make new structures from them, close the files, and then generate new files from the structures I made, right? So I kind of have that idea in my head, and we're slowly getting there. I also know that I want error propagation, so I want a singular error type to be passed between everything so that it's very easy for any function at any point in the line to say, nope, I'm raising an error and this won't work. Whether it be lexing, parsing, compiling, what have you. But learning a language, I mostly just try and figure out what I want to do. Like, we should learn a language tomorrow or something. If you pick a language, I have a giant list of languages here. I think I have to show you a black screen for a second. I'm sorry, I am still here. I am just opening a file that may contain sensitive data. So I am keeping it on the down low. There is now no sensitive data on my screen. I can show you guys what is going on. Here's my list. I have a bunch of languages I want to learn. If you want to see me learn one of these tomorrow, let me know. I'll probably do it. And if you have an idea for what to make in it, that's even better. But yeah, we can learn a language together, and you could see kind of my style, I guess, in real time. Whoa, you are amazing. I'm not amazing, my guy. These are just languages that I've heard about, but I haven't actually written a program in. I probably could. I can write one in Zig. I've definitely written in Zig before. Carbon is new. Scheme is just a really old Lisp. Perl is like regular expressions extraordinaire. E and D are actually very interesting to me. They're like mixes between C and Python, and they're very cool. Genie, Elixir. But yeah, those all look very cool. We can learn one of those anytime, because they all kind of, you just need to learn how to express yourself or your ideas through them, right? How do you do an if? How do you do a variable declaration? How do you access the contents of a string, right? It's all just learning how to do it. And most of the time, I just use Google. Like, I have it open all the time. I read, what does this function do that I've used a million times already? Like, I don't memorize that stuff. I just look it up. Because sometimes they change. fread used to be a little different in what it returned. In that FR and FEOF weren't so prevalent. It's already stored in internet. Exactly. I don't have to like keep all these function declarations in my head and all the arguments they take. I just need to know that they exist and that I can access them. Like FEOF is in C standard IO for C++. But you should know that in C standard IO, that's actually standard IO.h in C. So you have to include that. There's just some basic stuff. Everything's basic. It's just about how to get what you want done. Because like writing a compiler, you can probably do it in any language. I could write a compiler in Lisp. It would just take a lot longer and be a lot harder, right? At least for me. People write AI in Lisp. That was actually the first place AI, the first programming language AI was ever written in, is Lisp. But yeah, I recommend just make a plan, make something. What do you want to make? Do you want to make a calculator? You want to make a game? Do you want to make a lottery number generator? Do you want to make an image generator? Do you want to make an image decoder that tries to guess, like, that tells you what color is at what place in a picture? Like, there's so much stuff you can do with code. You really have to have a high-level plan of what to do with it. It's like a hammer. If you're just given a hammer and go, can I hit nails? It's like, Well, yes, you can hit nails, but ideally hit the nails in the right spot to make something that you want to create, if that kind of makes sense. Because code is just a tool. So we can now lex a single token. Lex the next token from source. Point to it with beginning and end. I think that's self-explanatory. So now we basically just need to say beginning is equal to the source, and so is the end. So these also cannot be null. I need to pass, let's see, in Lexing. If not source, or not beginning, or not end. See, these pointers can't be null, but the pointers that they point to can be null. So that's a little confusing, but that makes sense. Thanks for your explanation. Anytime, dude. Of course. It's just, of course, it's just my opinion. Other people may tell you other things. Why the variable is pointer path, not path? Where? Pointer path. Here? File contents? The specific one or any variable? Like, why is it pointer? Because a type in C, everything has to have a type, right? So it's very strongly typed. If you have a variable, it has to have a type. And that type designates how the compiler can handle the underlying memory address, right? So a type and a memory address makes a variable declaration. And the memory address gets to be substituted with this name, this identifier that we get to use. And you bind that in the symbol table to its type and its place in memory, the actual data. But a character is only 1 byte in C, in most C applications. So if I just had character path, that can equal A or B or C or any other singular byte. But I can't actually write like this equals ASDF. You can see that it'll say incompatible pointer to integer conversion, initializing char with an expression of type char5. See how it has an array there. So this is actually a character array. That's how strings are implemented. And arrays in C are actually just memory addresses, right? So an array could look like this, right? Here's the memory address it points to, and then here's 1, and then you get to 2, and then 3, 4, and it would probably be 0 indexed, right? C is so good. You are absolutely right. C lets you use your computer. Oh, but an array is just a pointer. So this pointer points here. And like we said earlier, there's always a null terminator. So there's actually a 0 here that ends it. This /0 null terminating character. So then you can loop over, okay, index 0, I read a character from this place. It's 8 bits. Okay, index 1, you just go up here and read the character from here. You basically just get a contiguous array of memory. So it needs to be a pointer because an array is actually just a pointer, and strings are implemented in C as character arrays with a null terminator. And that's the format that we get passed arguments in. So you see here is a character pointer. So this is an array of character pointers, if that makes sense. It's a pointer to a bunch of character pointers, which then each point to a string or an array of characters. And in this case, this is the arguments we're being passed on the command line. So this right here, this example in the command line, is actually argv1. So we have a pointer in memory to this e right here, and that's argv1. So we keep track of that. But then there's a null terminator right where at the end, after the last e. So when you print it or anything, you just print until you get to that null terminator. Yeah, that's why it's a pointer, because strings in C are implemented not as objects, but as character arrays. And arrays in C are actually just pointers, so yep. In this array operator, it's actually just implemented in the compiler. You can get the same answer like this. Yeah. Times 1. So it's a little confusing, but you can also take the memory address and then add the index times the size of a single character or a single element within the array. And this is all this array operator does. It does this math for you. And then dereferences that memory address. So the array operator effectively writes this under the hood, if you look at how a C compiler works. Anyway, okay, so now we're parsing. We lex. Okay. So I think we have to define some constants like white space. Programming is so much more than the Python I learned. Oh man, yes it is. Python just scratches the surface of like every little part. It's like, ooh, there's for loops and while loops, and okay, I get it. And then you start learning about like how actual programs are implemented in the real world, and it's like, this is a lot more of like file handling and data sets and using 8 different languages in a single project just to get what you need done. Like, companies don't care. If the developers can maintain it, it's like, well, we'll pay for it. So it's a win-win for companies to have lots of languages. Which is like why Google keeps coming up with new languages. They have people doing the same thing I'm doing, just sitting here going, I want to make a compiler. So if only spaces are white space, we'll also treat, I think, /r as white space. We're also going to need a delimiter. So a delimiter will be something that ends a token and begins another one, no matter what. So I think we're going to have like the colon there. I don't know. Let's think about this. Let's look at our example. Also, just to make sure no one's hopes are got up too much. Also, I missed a follow at some point 45 minutes ago. There was never a chat from them, which is probably why I missed it. I'm sorry about that, but Dungeoneer3, thanks for the follow, my guy. Or girl. Or thing. Animal. Cannibal. Are you a cannibal? I'll call you a cannibal if you would like. So this is our example. We would like to parse, first of all, lex, I guess. We need to separate. So beginning, we don't really need to move most of the time. Ideally, beginning will always be done. We could like seek past white space, right? So let's do that. We're going to say I guess we can do something like this. Okay, so beginning is set to the beginning of the string we are lexing, the bytes. And let's make sure string, no, string.h. Yes, that one. So this str cspin returns the length of the initial part of string 1 not containing any characters that are part of string 2. So by adding this to the memory address, we should skip beginning past all the white space, all the characters that aren't white space. That's not what we want. So we actually need to use str span. So however long the span of white space is at the beginning of beginning, skip that. And then say end equals that. So we skip the white space at the beginning. Wonderful. Now, end is basically, we're kind of going to do the same thing, if I am correct. But this time we skip 2 white space, but also delimiters. And I believe white space is also a delimiter. Sure. We'll get there. So then, let's see, what do we have then? I would like to print that out. Lext %s, do I use dot star? Is this how I do that? And then I do end minus beginning from beginning. That is how I do that. Wonderful. So this will print out however long, this will print out from beginning to end effectively. And we lex our source, we parse our contents. We're ready to try it again. We got an error because we didn't include string.io or string.h, not .io. Wonderful. So we definitely lexed something. It does not look correct. I don't even know what this might be. So we skip all the white space. So what if we just skipped white space? Also, am I freeing this before using it? Let me just make sure. Oh, yeah. See, that was my issue. It's fine. We're fine. Everything is fine. Okay. What did I change? I changed that. I don't need to change that. Okay, it's still broken. Because I didn't fix it. I'm a genius. Yes, thank you. That is me. Oh yeah. Hey. Okay. Right. So now I need to say while I would like to just do this for the whole time, right? So I kind of want to do this. So while lex source beginning end, printf lext %s, and then we can put in star in. We have them here directly. We don't need to dereference a pointer to a pointer because we just have a pointer. What's your issue? Oh, this isn't a Boolean. So while there is no error, keep going. Otherwise break, obviously. Okay. I figured it out. Did I put that in the wrong place? I did. Woo! That's some messed up C right there. This is kind of cursed. This is hard to read. So we basically have an error, and we assign error to the return value of Lex, right? Then we get the type of the error that we just assigned to, and if it is none, we continue. Valid logic, right? I think that's fine. Let's try it out. Ooh, yeah. Okay. We've learned something. And it is that this needs to be beginning. Okay, nearly. This needs to be beginning. That doesn't make sense, does it? That doesn't make any sense. This needs to be end. Is that right? So from the end of the last token, we begin. Yeah, that makes sense. Well, you know, it would. It would to me. So we just keep saying Lexed. So how do we ever stop Lexing? Right? That's the problem. We can Lex a token, and we get it from beginning to end. But this may be 0. Like, this may return nothing. So let's try that. Okay. Not a bad move. We got A and nothing else, which isn't great. So we have a beginning. It's set to what we are given as the source. We skip any white space. This would mean that new lines get kind of included. What if I just did this? We'll try that for now. Okay, nope. So we set beginning to source, we set end to beginning after skipping white space. And then we skip everything that is not in delimiters. In which case we get A because there's a space. So when C spin is 0, it means we may be already on top of a delimiter. So let's just remove the colon for now from a delimiters. Hey, haha. All right. We have successfully, in C from scratch, accepted a file path as an argument. We get the contents of the file, and we're actually able to parse and Lex into tokens. That's incredible. That's more progress than I thought I'd make today. Wonderful. That's beautiful stuff. Should I return like a syntax error if we get 0? Is that a syntax error? Is that just how the end works? I don't know. We'll see. We'll see. Okay. Let's see how we're doing. So we have tokens now. Now we need to identify what these tokens are and what to do with them. So isn't that fun? think we could do something like last token. Let's do prev token. I guess token is a beginning and an end, so we'd need like prev begin, prev end for each one. So maybe it would be worth it to make a structure for the parser, like a token. We'll see. We'll see. Whoops. Okay, so a integer 0 equals 0. So the idea would be that upon encountering a colon, we look back one token to get our identifier and ensure that it's a valid identifier. Then we look forward one token and ensure we have a type. And that is all we need for a variable declaration. Then we're going to also have to optionally check for a variable declaration with initialization, which is a token after the type, an equals, and after that, some expression that may be multiple tokens. Interesting. This is a very flat Lexer, so maybe the parser should try and tree this up a bit. So I'm going to need to create an AST. I guess I need to kind of define what the actual, also comma should be up by itself. So this will let me make this a little better. Okay, that didn't quite work. If string equals beginning still, right, and star n plus equals 1, no? So this should make it just 1 byte by default. This will also mean that we never get here. Let's think about this. So if end equals beginning, so what I can do is say if source, I guess I should say end equals, I guess this is really beginning. If beginning equals a null terminator, shouldn't we return? Because if we are beginning at a null terminator, that really shouldn't work. Why are you not working? Pointer end. Hey, look, it nearly worked. Now we just need to define parentheticals as stopping the expression from continuing. Nearly. Let's try that. That's a little better. Polyvoid, just with the follow. Thank you so much. It is wonderful to see more people following. I really appreciate it. There's a Discord down below if you want to get notifications every time I go live. I make an announcement in this channel. And you can talk. Message me, message other people that watch the stream, make friends. Do whatever you want, as long as it's nice. Thanks, Polyvoid. First time chat from you. Very nice to hear from you. How's your day going? How are you doing? Me and Angel have been hanging out and programming a compiler for fun. We've created a Lexer so far from scratch in C. I saw the stream on Discord, so join. That's right. Yeah, Twitch following, even when you turn on notifications, you still just get like input into their algorithm. It doesn't actually work the best. All right, I think this works well. We handle the end. We handle tokens that are singular in length. So we may begin on a delimiter is what I'm saying. Let me just make sure this. So a colon integer equals 0. A colon equals 0. So that's a redefinition, or a reassignment, I should say. Then we have defun, foo, open paren, a integer, blah, 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 blah. Perfect. We are having fun. We're Lexing. We've created a Lexer. And it's actually rather a performant one. It uses the C library everywhere it can, and there's not a while loop in sight, other than actually lexing all the tokens themselves. But in the Lexer, not a single while loop. That's fantastic. We should probably also do the same thing for parsing. I'm very new to learning about compilers. That's okay. So is some other people in here. Not everybody is skilled right away, right? Plus, you'll probably be able to learn a lot watching this stream. If you have any questions, I will gladly take a 20-minute detour and answer them. I do it all the time, I promise. And I care about your knowledge. I want to make it understandable for you. Okay, so we can now parse an expression from contents. We actually don't parse an expression, we just lex. So we need to start conceptualizing the AST. Let's think about this. We're going to go into a scratch buffer because we need to think about this. So what do we need? What data needs to stay persistent throughout the life of a program? There has to be known identifiers, because a reassignment expression or statement is not able, like you shouldn't be able to do this because we don't know the type of B. So B has to first be declared with a type, and then we can assign, but that means that this declaration has to add to some list. So one, you need some, oh god, company mode, or not. You need some list of identifiers that are known. Ideally with type information, right? As well as the literal value, possibly. Literal value, memory address, I don't know, something like that, or something. That sounds reasonable, because without that, we can't really know that B has been encountered before. We need some list of things we've encountered before that we know what to do. Okay. Oh man, that's kind of a difficult one. If we have global, so we're going to need scopes. These need to be scoped, i.e. nested, to allow for what? Why did I say that? Okay, so allow for shadowing of global variables, global identifiers within functions, for example. Actually, this may even allow us to implement let, which would be cool. Let is something from Lisp, and it's very nice. It's cool. You can just say let a be an integer and equal to 5. And even if you have this a integer, then within this block, no matter what, a will refer to this declaration, and it will not change this declaration at all. But that's a little complicated. We're not there yet. I'm good at getting ahead of myself. But we definitely need scoped identifier definitions or mappings, because when we look at A here, well, this is in the global environment. But if we're compiling this function, if we use A in here, we kind of want to be able to name this A and have an A global. So when we run this function, we'll effectively enter a nested scope with different environments. Okay. So I think this could be implemented as like a very basic linked list. Let me see if I can sketch this out in a way that makes sense. I'm off, going to join the Discord. I'm going to my psychologist. All right, my guy. It's cool to see you, Polyvoid. Good luck at your psychologist. Have a good appointment. We'll see you when you can talk. And I very greatly appreciate your presence. Thank you for coming. Hopefully we can learn more together some other time. I'll see you soon. Bye. Okay, so we need a scope, which is going to be some structure with mappings, supposedly, of identifier to type and value. I don't know. Let's just keep it at type right now. And going to need lots of these. So we might have A, which is an integer. Okay. Because we don't ever actually need to get the value of a variable in the compiler. Will the compiler be open source? Absolutely. Should we, let's do that now. We're going to use maggot and create a new Git repository. Oh no, I screwed it up. We're going to use Emacs and delete a new Git repository. Can I delete a directory? Yeah. I'm in a nested folder. That's why that I had to cancel that. Make a repository here, please. In the beginning, there was darkness. Perfect. I like the dark. We'll add the README, the CMake. We're definitely going to need that. The source. And let's see. Let's building. You're going to need CMake. Greater than or equal to 3.14. Right? And then you're going to need a C compiler. What else? That should be it. That's literally it. Okay. Any C compiler. Wonderful. Then we are just going to write, oops, sorry, I'm blocking chat on my second screen. A source block in shell mode And let's see, this should say CMake. First, generate a build tree using CMake. Finally, build an executable from the build tree. I think that's self-explanatory. Note. Sure. Note. Shell commands shown assume a working directory of this repository. Good enough. That just means run these commands from this folder, please. So we actually just need to say build, and that should be enough. We could add this, but it's kind of ugly and we don't need it, so I'm just not. Emacs or NeoVim, which is the better one? For me personally, Emacs, because that's the one I use daily and write configurations for and understand how to use, right? To get what I want done. NeoVim could be better for me. I've tried it before. I can't get into the Vim key bindings, the HJKL and the modes, and I don't like memorizing which key map I'm in at the moment. Like, oh, am I in insert mode? Nope, I have to, okay, what button do I press to get out of it? Okay. And then once you get out of it and you're in a different mode, then all the buttons do different things, and it's like, that's too much for me to remember. My brain can't efficiently work like that. My brain works when I have Emacs. But I don't think one is necessarily objectively better. Subjectively, to me, Emacs is better. Are you have any config files for Emacs? I do. I have my config files, I think, somewhere here. Yeah, I have emacs.files. So in org mode, I kind of write it in a, can you share it? I could. It's kind of specific to Windows and my machine, but I can definitely share it. It's written out in this literate programming style in org mode. So everything that is in the actual configuration is written about. And usually, at least, there's some stuff in here where it's just in there. But you can see that there's performance tweaks, there's opening new frames in full screen, extended Lisp source directories, disable unnecessary GUI elements, initialize package management, load myinit. There's a whole bunch of stuff. And there's multiple files. There's also myinit.org, which is all like my email and setting up other specific stuff. But yes, I can share it. If you want, I can make this Git repo public and then get the link in the Discord later today. Because currently it's a private repo and stuff. If that sounds cool with you, we should link these. CMake. And C compiler. We're just going to link to GCC. Yes, because we like GCC. The GNU compiler collection, and then CMake. Make that a link. Yes, stage. So we link to CMake, we link to jcc.gnu.org. That's how you build it. Usage-wise, just gonna move that up there. Usage-wise, with an executable ready to go. I guess I don't really need to say that. We can say run the executable from a shell or terminal. I'm just going to say from a shell. What's the difference between make and CMake? A giant one, and they're different languages. CMake is actually usable in modern software. So if we take a look at the CMake configuration file, this is it. I know it looks kind of complicated, but it's not. There's basically functions that you call with parameters, and you can set different things. So we have an executable called func with one source file. If we need more source files, we can just add them. Like if we want to add the parser into a new file. You can also add all sorts of things based on targets. You can add different targets. So like in make, they're called rules, I think. But for example, for light, I use a docs target to be able to build a website, a local website containing developer help. And then I use like I'm eventually going to use cpack to pack the executable into an installer and do all that. CMake is basically C++, and make is basically C, if that makes sense. It's basically make, but with a lot of fancy bells and whistles. And it also doesn't actually run any of the commands itself. Like you can use CMake and make together because they're different things, if that makes sense. Like if I run CMake-G, you can see that you can generate builds for Visual Studio or make. So you can make a make file using CMake. And then CMake will generate a make file, which you can then call make on. Is CMake OOP? Haha. OOP, is that like object-oriented programming? I would say no, you can't create objects. You can create variables and configuration options, and there's like booleans and generator expressions, but it's not even Turing complete. It's not really a finished language. But it's just way better, in my opinion, because CMake allows somebody on Mac OS to generate build trees for Xcode and build it with their own compiler, whereas I can use Windows and MinGW with the minimum GNU workspace and basically be able to... I'll use CMake. You got it, my guy. If you have any questions, I'll try and help you out. I'll warn you, C is not forgiving, but CMake allows you to create actually cross-platform programs. That, like, you can run these exact same commands on Linux or on Windows or on anything, and they'll generate an executable, given you have the proper dependencies. Run the executable from the shell. They path to source, do some source code as the only argument. I'll use CMake. Yes. But yeah, CMake means that basically everyone is able to run it, as long as you write it in the proper way. Hey, Polyvoid did join the Discord. I appreciate that. I know he's gone now. Currently, we print out the furthest progress we are able to make. Eventually, we will output compiled source code, whatever that may be, assembly or C code or whatever we end up compiling into. Fun. With that, okay, I think we may actually be able to go create a repository finally. We have the basics. We need a license. Let's go steal the MIT license from somewhere. Thank you. Boom. Okay. We are now open source. Hooray. Get the license in the Git repo. And say, ready, set, go. I wanted to create a compiler, so I started doing that this morning. Another compiler, so I started doing that this morning. We have made more progress than I thought we would. And I thought we would. We'll just end there. Currently, we can Lex some very basic source code into tokens. Yay. That's good enough for me. All right, so with that committed, I now just have to create a repository and then add a remote. So I think let's just go do that on GitHub. Sure, why not? GitHub, new repo. We're gonna call this the fun compiler. Let's make sure that's not a thing already. Okay, this is a thing already. This is basically, okay, that's not a similar thing at all. This is creating visual representations of conceptual notions characterized by compilation theory. Not a compiler, not really worried about that. This is a compiler called Fun Compiler, so the name is taken. Hey, he actually got pretty far with it. What's it written in? Hopefully C? Oh god, yes, in C. It's just named confusingly. What is owalker.ok? Maybe that's a test. I see, that's probably a test. Or this is, well, that's confusing. He has some assembly there. Anyway, he called it the fun language. So it's the fun compiler. So if it's not the fun language, we should be fine. Because, how about Supreme Barnacle? Yeah, I don't think so, GitHub. Don't have to worry about that. So this is the fun compiler, but it's the fun language. So we'll make the fun compiler that doesn't make the fun language. The compiler I made just for fun. We'll put a smiley face. Please don't initialize it with anything. Cool. Okay, wonderful. I'm going to need that link, and then we're going to use maggot to add a remote to my local Git repo. What button is it? It is, does anybody see remote in this list? Oh, it's a capital M. So I need to add a remote name. We're just going to call it origin, like normal, and it's going to be there. We'll set it the push default. And now we need to push upstream creating it. And also probably rename the branch as it named master. Branch. Actually, I can probably do this like this. Hey, we did it. There is the link in chat if you'd like to go check out the source code or maybe even build it yourself and run it. Take a look at how it works, whatever you would like to do. We are not going to need packages. Ooh, I'll add some topics. Why not? Compiler. Fun. Let's see. Compiler. There's a lot of tags people use. Compile, language. Perfect. We'll go with that. Why not? Give it some fun tags. Those are always fun. Cool. Yay, it's up. And running. Is there something I forgot? I mean, we don't have the example code yet, but that's not really important because the syntax isn't defined. Oh yeah, that's what I was doing. Hopefully this doesn't show anything bad. I'm just going to branches. We don't name them master anymore. We name them main. Wonderful. And then I need to go here and run these. Thank you, Git. I think I can just do this from the terminal. Yeah, I'm in the right spot. Git branch, create a new, so this renames master domain, fetch origin, branch, update origin main to main. Yeah, so sync these two and then set the head of origin. Yeah. Boink. Wonderful. Now if I do git status, your branch is up to date with origin main. And now if I look in git here, yeah, it's main. Wonderful. There is still origin master here. I could delete that branch, but I don't need to yet. Ooh, that was a lot of git. It's now fully open source though. Everything's available. And we can do more than hopefully just Lexing. Well, I guess at this point we need to start parsing data types, right? So we need to figure out what is a symbol or an identifier, like just a string of characters. And how can we validate that? So let's just say int return 0 upon success. Valid identifier. So while ID if, oh man, I don't remember where these are from. Maybe I should just have identifiers be anything that don't have white space in them, right? So so if string pointer break returns null, we can return like 1, otherwise 0, right? So if string pointer break returns null, searching for white space in the ID, then that means that there is no white space in the ID. Should I do delimiters? Because delimiters includes white space, but also has some funky stuff. That's probably important, not to have a delimiter in the middle of an ID. It's not possible to have it, but so I guess we could just argue that everything that gets lexed is a valid identifier, right? Because we could just lex anything. But this would be the thing that gets lexed due to how the delimiting works. So then this would be an invalid token and fail. I think that's fine. So anything that gets lexed as a single token is a valid identifier. Let's just say that. Now we need to identify when this happens, right? Okay, we're also going to need like an environment type of thing. So what if we had like environment set and we get a pointer to an environment? See, what is an environment? We're going to need some structure called an environment. This is going to be like a scope. And first of all, it's going to contain an environment, a parent environment. I've already been streaming for over 2 hours. Oh God. I'm sorry, everybody. Okay, this is amazing. We're making a compiler. I probably only have about 15, 30 more minutes left in the stream, but I'm going to milk it for all it's got. An environment has a parent. It's also going to need some sort of like the mapping, right? So actually, I want to go look at how I did this in Light Graphics, because I think I did this very similar thing for the Lisp environment. Yes, how did I do this? I stored within the environment, I stored a list, a linked list of bindings, and the bindings contain okay, and the bindings contain a symbol mapped to a value, yeah. So I could, within each environment, just have some sort of strep binding, if we're going to do all this way. Bind, cool. And this binding is going to be some identifier mapped to what? I guess I'm going to need a type definition. Right, so we map within our environment this ID we get, and we're at least going to need its type. Right, we're at least going to need its type. So maybe this is where like the AST itself comes in. Oh God, this is about to get very messy, and I'm sorry. So an ID is bound to a value in the environment within a binding. And that's a linked list of bindings. Now, of course, we could implement this as a hash map as well, but I don't think this is necessary for the compiler at this stage. So then to do would be API to add binding to environment. Right, so when we add a binding, so not only that, right? Here, let's do a pretty one. We also need API to create new binding, right? We need the API to create a new binding and add a binding to an existing environment. To do API to create new environment, right? I guess environment set is what this is. But I need the actual node that I'm going to be, okay. Okay. Let's think about this. So I'm going to be compiling along, getting tokens. And given I parse certain tokens in a row, then that means I should be able to generate a node. Is that correct? Is my thinking correct? Also, I ask a lot of questions. I don't expect you to answer, but I do appreciate if you do. So here's the thing. If we have a node, what does it need to contain? Right? Because this node is part of the AST. What are we going to do with the node? We're going to generate the program, ideally from a singular node, which is the root. All right. That sounds doable. So we're going to have some root. And the idea is it's connected. Maybe it's a binary tree with a left and a right. Let's just sketch that out. Let's see what would it be like if that's the case. If it's a binary tree, maybe with a value here, right? Like operator. Is that reasonable? So what if the operator went like here? Right? I guess it has to be the one side. So let's say we have plus. Then on the left, we could have an integer. So it's going to require some doing. And that integer would have a constant value somehow. Of 0, let's say. Well, let's just give it 34. We know what we're going to do. We could have another integer on the right. So maybe integer is a type of a node. So maybe nodes have types and a union type value. So if we had enum type, and then we could have a union node value, node type. Let's just go none. That will be our null. We'll have none. I kind of like that. And as a value, well, we're also going to have integers, right? So we kind of know that. What's the biggest integer in C? I think long int. So just long. How about we do this? We're going to do a bit of a type def. I did that the wrong way, did I not? Okay. So we have a node which has one of these types and one of these values. Based on the type, we can use different values. Valid. That sounds valid. Okay. Here's the thing, though. Not only does it have a type, right? So I'm just going to do this. Do I have any other enums? I do. We're going to add this in now. What is it? 1, 2, 3, 4, 5, 6, 7. Is that actually what it is, or is it 6? It's 6. So if you haven't seen this before, an enum is basically named integers. See it at the bottom here in the type. It says type int value 0. Here we have type int value 1, type int value 2. So by putting an enum called max, you can then assert that this equals a specific value. And then if I go in here and add a new error type, like I want to add error file, let's say, then this assert next time I compile will fail and will actually tell me exactly the line that I need to go to as the developer and add in a new handling for that error type, if that makes sense. So that's kind of a way to have the compiler help you out. And I'm going to do that with the error types and node types. Very cool. So I feel like your eyes have glazed over a little bit, and understandably so. But I promise it's actually not too bad what we're doing. So what if instead of like that, could I do, let me just copy this. So what if on the left it had plus? Okay. Then from the plus, we go out to 2 integers, which we're gonna have to do like this on. Sure. Okay, still one more. Okay. You are an artist. Lamau, thank you, my guy. This is my this is my next painting. It's gonna be called Hexagons or the Bestagons, and I'm gonna sell it for $3 million. Starting price. I'm actually just doing some sketching out of what the AST will actually look like for this program. Because we have this flat list right now of, let's see, where is it? We have this flat, where is it? Very flat list of tokens. And this really doesn't have any meaning. Like there's no control flow here. There's no, oh, do this before that. It's just tokens. So now we have to say like, okay, we want to make an expression. We want to put these tokens together, compose them in such a way that they form larger pieces, like defun, foo, argument list, etc. So to do that, we need to unflatten it effectively. We need to give meaning or assign meaning to these tokens. And to do that, we're going to, we're going to end up storing everything in nodes, because at the end of the day, everything is a tree. Like even mycelium starts looking like a tree. So I just drank some water. And before I was thinking that each node would have an operator position and then a left and a right, which would look like this. So with a left and a right node within each node, you can kind of recursively point to yourself. So root could point on its right to a node that says none, or could point to null, which we could probably just do like that. That looks better. So the right side is null, but the left side could be an operator, which could be its own node, or a binary operator, I guess. Ooh, how do we handle a trinary operator? Ooh. What if, instead of having left and right, we had a linked list of nodes within each node as children? Ooh. Okay, so that would allow, for example, question mark to have some like condition, have some, and then values based on that condition. So let's say we return like 420 in this case. Okay. I think I like this, because then this could be an integer as well. It's like 69 or whatever. So this ternary operator, if we have multiple children, would be able to do some cool stuff like this. I think that would be worth it, right? So we're just gonna have a struct node pointer children, right? Child. We're gonna have to have children. So is this a node pointer pointer? I think this is a node pointer pointer. Or we could just have like a fixed array, like 4 children. What should we do? You think we should have fixed size children or just any amount? We're probably not going to ever need more than 3 or 4. Fixed size children sounds really funny. Would you like your child to stay in as a fixed size for the low price of $3.99? You can lock your child in. So let's say they have children, right? We'll support ternary operators within the AST. So then, hey, xviv bot, how's it going? First time chat from them. How's your day going? We are making a compiler, in case you didn't read the title. Angel says hi. Okay, so we have 3 children, let's say. Are you a bot? Haha. Right? He's not suicidal enough to be a bot around here. No, I am not a bot. Lamau. I'm good. Hey, that's good to hear. That is good to hear, xviv bot. We are having fun here. And you? I am doing rather well. It's a morning. I woke up and I literally just thought, like, I don't really have a plan. I just want to make a compiler. It sounds fun. And that's what I did. So then I decided to write a bit of an example language. And now we're working on compiling. So far, let's see, does it compile? We've done a lot of stuff so far. Hey, it does. So far, we can lex a file, a given file, into arguments, or not arguments, what am I saying? Into tokens. So all these are separate tokens, and they will be able to be parsed into an AST that we are defining now for a new language. Yeah, I just decided I want to make a compiler. So I just decided, let's just make a I don't want to write like a C compiler. That's already been done, right? I'll make a new compiler with blackjack and hookers. And here we are. Here we are. We started just about 2.5 hours ago, and we've actually made some good progress. We need a node. Also, I'm thinking that the environment could be a node itself. Ooh. We could allow recursive pairs like Lisp. Ooh. You did all this in 2.5 hours? Yeah, my guy. If you want, after I stop the stream, I have to go pretty soon, 15, 30 minutes. After I stop the stream, you could go back and watch the VOD and watch me write all this code. The beginning is a lot of just like getting file IO done, so you might want to skip past that if you're used to C file IO, but you could learn a lot if you don't know C file IO, just from the beginning 30 minutes, learning how to get a file size, allocate a buffer for the contents, etc. I really appreciate the sentiment, though, that this is impressive to do in 2.5 hours. Because this feels like I've been working so slowly this morning. I've been kind of putting myself down a little bit internally. Like, this is all I've gotten done. I spend 3 hours and I have nothing done. But it's good to hear that somebody thinks it's sizable. It's some progress. I feel like I haven't even got to the parsing stage. All I did was make a Lexer. In either case, we do have to start parsing now, which means this is going to have to change. I guess we're going to have a node program. Is that right? I don't even know. We're going to call this expression. Sure, why not? I wonder if we could make a runtime evaluator as well as a compiler. Ooh. Because then we could use the runtime evaluator to have compile time code. Ooh. Okay, I'm gonna add that in my little to-do message. Also, we did part of our to-do. Hello? Control C, Control X, Control B. Okay, maybe I was pressing the wrong buttons. Now we're here, we're parsing tokens, and then we have to compile into assembly or something. Oh, XVivBot hit me with the follow. That is wonderful. Thank you so much for following. I really appreciate it. Remember, Twitch kind of gets finicky with the notifications, so if you'd like to be notified every time I go live, you can go down below to the Discord, and there's a channel there where I post every time I go live, called announcements, and you can also just talk and join all of us watchers, make some friends. But that's only if you'd like. I don't want to pressure you too hard, but do it. Okay, so we should probably have like a none expression macro, right? None? Sure. I'm getting ahead of myself. Basically, let's make a none p. That's not ahead of myself. So when a function ends in p, it usually means predicate, which means it returns like a Boolean, 0 is false, 1 is true, just so you know. And none p is going to take in some node. So this function like macro will take in a node. In this node, we are then going to access its type. And if it equals node type none, so this will return 1 when this is matching. Yes, so that is a predicate. That is correct. 1 means success. So now we can check if a node is of none type just by writing none p instead of having to write this crazy stuff out every time. And while we're at it, we can make one of these for each type, which is just 2 right now. In any case, we may have to save our tokens that we parse. I do think we're going to have to do that. Okay, So I'm just going to start thinking out loud because I started going silent. What's happening in my head? We are inputting a string to this parse expression, and we could actually keep track of byte offsets from the beginning of the string as we lex the entire string, right? But that's not accurate, because what we need to do is actually parse multiple expressions from the string. And as we parse expressions, we should compile them. Or we could parse expressions until we build up the entire AST. That may be what we want to do for this language. So, okay, let's see. Oh man. So if this is the AST, I can't really compile with half of it done. Like if I parse expression, I'm just gonna like get condition, right? Or maybe I just get well, that's the thing. So a program may have multiple expressions within it that get called sequentially, right? So a single program, for example, okay, so it seems like we're gonna have to have a, oh man, where am I? I'm really lost. It seems like we're going to have a dynamic array of children. That way the root here can have any amount of children that will act as subsequent expressions, right? So I guess the idea, what we're really saying is that a program can be defined as a node. And everything in the program that needs to be done should be able to be expressed through this node API and this node data. So we have this node, and ideally it just points to one thing, but it may point to a lot of things. So, okay, but what is this node? What is this node specifically that refers to the whole program? Because it's not a none type node. That is actually a new type of node, is it not? It is. So then when we compile, we can ensure that the node we are passed is a program, because we don't want to compile something less than an entire program. Or, okay, or we do something like this, which contains a node root. So basically, we can have a program which contains a node, or we can have a node contain a program. To me, you don't want to compile a half program? Lamau. I don't even know what that would mean. That'd be hilarious. Like, just get to here, compile that. Screw the rest, we don't need it. That'd actually be interesting, like compile as you go. You'd have to write code in a very weird way, where you tell the compiler what you're doing before you do it. It's doable, though. It would just mean that each time we parse a new expression, we add it into the root, and then it would have to find its place. And the compiler would tell you a warning that your variables are not used. Lamau. It's like, yeah, we compiled half of it, and the stuff we didn't use, yeah, we're gonna blame you for that. So I don't like this. I don't think I want a program structure. I want a node to contain a program. All right. I should add some to-do. API to create new node. And then API to add node as child. I think that should be all I need, because then I can use the create node passed into the add node as child. XVivBot says, is this your first compiler? And when yes, why do you know how to write a compiler? Oh, and when yes. So if I answer yes to the first question, why? So is this your first compiler? Why do you know how to write a compiler? Okay, I understand what you're asking now. This is not my first compiler. If you actually go down below to the links, right where the Discord is, you can also see my GitHub. And if you go there, you can see some of the projects I've worked on. In the past 6 months, I've made a text editor, an OS, and I guess like 6 months ago exactly now, I created Corth, which is a stack-based programming language that compiles to a dynamic executable on both Windows and Linux, x86-64. I think that's the last compiler I've written, but I have also written compilers before that that are not on GitHub. They're basically just in my drive here. Like if we go to projects, see E is a language, P is a language, EV2, that's E, V2, that's another language. Corth, that's that one that's public. We have Mirai, which is like a C-like language. We have Lenser OS, which is my OS, Create GPT, a tool for making the OS. And then I did some like OpenGL stuff. But that's all within like the last year. So to answer your question, not my first compiler. I know how to do it because I've tried many times before and failed, as well as I'm very competent in C now. This programming language, I can write anything in it because I've used it for so long. Which kind of happens when you create an OS in a language, you tend to become better at that language. So I'm pretty good at C and C++. But I really enjoy Pascal. Like Pascal is one of my favorite languages. As you can tell, because my text editor, I've actually written the test runner in Pascal, which I think I may be the only program on GitHub whose tests are run with Pascal. It's fantastic. I don't like this all separated. Man, I am definitely losing steam. I've been streaming a little too long, but it's fine. At 11 here, I'm gonna have to get going, so we are on the downwind of the stream. About 10 more minutes. Let's see if we can't do something interesting in that 10 minutes. Are you interested in writing a compiler, XVivBot? Because if so, there are many things I would recommend. And are you interested in making a compiler specifically, like you want to make executables, or would a runtime also be okay, like a dynamic programming language like Python? Because if you want to make a dynamic programming language, Lisp is the best one to learn, hands down. Lisp as a programming language, making your own will just teach you so much about how computers work and how to conceptualize your own ideas into reality with all this crazy code and structures and stuff. That doesn't seem like it's possible. So I think we're going to have to keep track of all of our tokens. Is this true? So as we encounter tokens, we need to look back and forward. So yeah, I never wrote one, and I'm not really interested in writing my own one, but I saw the title and wanted to see how it looks writing a compiler. Awesome. That's totally fair. This is how it looks. It's a lot of just getting things working and then slowly refining them. Like at the beginning of the stream, we had nothing that looks anything like this. We had empty files, right? But slowly we are able to lex into a flat list of tokens, right? We can get this flat list of tokens separated how we need them. So now we need to turn this flat list of tokens into a tree-like structure that looks like this. Because then this gives control flow to the program, essentially. So if you need to add a number, then you can say, okay, to compile this add token, or this add node in the tree, then you can go to integer and down to... Is this Vim? I don't know why, but that's funny to me. Thank you, Tree Mosher, for the first time chat. What is up? How's it going? I will let you know we're about to end the stream about 5-10 minutes, but we streamed for 3 straight hours. There's a great VOD available that are going to be available once the stream is over. Hi, sorry for dumb question. I don't think the question is dumb yet. Just so you know, I think no question is dumb if you're willing to ask it in a group of people. Did I just save Scratch? I think I just saved the Scratch file. That was a mistake. Whatever. Tree Mosher, to answer your question, this is Emacs. I was just making sure you were going to stick around. Emacs is the opposite to Vim, effectively. But it's still... I wouldn't not use Vim. Vim is fine. It's just not for me. Oh, whoops. A lot of people do think it's Vim because of just how I have it configured. I have I wrote my own theme, and it kind of looks a lot like Vim, which I didn't even know. I've used Vim a total of 3-4 times total. And most of the time it's when I'm on a Linux machine going, what text editor do I have? What's the core difference between Vim and Emacs? I am just learning about Vim. I saw mention of Emacs, but haven't seen it before. Okay, so we have 2 questions that are very similar. One from XVivBot, one from TreeMosher. Let me give you an idea of what Emacs is, using actually my own... Here, I don't want to leak my IP, so I gotta do this. I'm sorry. You folks will be back very soon. Just sensitive data. Okay. So, effectively, I'm writing a text editor that is based on Emacs. So, when I run it, it will eventually open. This is my text editor that I've written. And you'll notice that I can navigate around using either the arrow keys, like any text editor. But the main navigation is with Control F for forward byte, Control B for backward byte, Control N for next line, and Control P for previous line. Does that make sense? So you can kind of go forward, backward, next, previous. And with those 4, you can hit N and P with your right hand, hold Control with your left hand, and then hit B and F with your left hand as well. So I can actually just hit 4 buttons, just like in Vim, to move around. Right? They're just not all next to each other. So the idea behind Emacs is that it's extensible. Emacs can do anything. So if you wanted to, we could go into how things are defined, and we can see, oh, this is actually how the when macro is defined. And where that comes into play is you can actually write in a custom programming language. In this case, it's light Lisp. So let's say we wanted to multiply 12 and 12 together, right? We can press Alt-E and evaluate the current line, You see the text editor evaluates this programming language, this line, and we actually get the answer. And you can do all sorts of stuff like this, and that's actually how forward byte is implemented. So if I go to the beginning here and then press Alt-E, you can see that my cursor is actually moving forward by 1 byte. And I can also say forward bytes 4, for example, and press Alt-E, and now it goes 4 at a time. And not only that, there are symbols, so variable definitions. Hey, look, I broke it. Probably just Stack Overflowed. My bad. My bad. If we try again to print out the key map, we can do that. Here we have the key map, which is actually just a list, but you can see like when you hold Shift, equals is actually rebound to plus. And if we find it somewhere in here, there's going to be a control. Let's see, where is it? Does anybody see CTRL? Here it is. So effectively, when we have, yeah, see, so Alt, when you hold any of the Alts key map gets used, and then you can use B when you're holding Alt. So you hold Alt, you enter this key map, you press B, you enter this binding, and then it goes, oh, it's bound to the symbol backward word. And backward word is actually defined in the standard library in LightLisp itself. If we take a look at that. I know this is kind of a tangent, but I hope it'll help. So you can see that backward word is actually a function definition in LightLisp itself. So you can bind keys using key maps to Lisp functions, which can alter your cursor, they can insert text, they can do math, it's a programming language, Turing complete. And this is how Emacs works as well. So if I go to my Emacs file, you can see that it's the same. It's Lisp, and you can effectively set variables and define functions and call them and do all sorts of stuff. A great example in the text editor, it's open, is that you can change the font size with this Lisp. So let's change it to 20. And now it's smaller, or 30, and it's bigger. You can change the font entirely. Let's go to Arial. So you can see that using this programming language built in to the text editor, I can create different editing experiences. Oh, that is cool. Thank you. Yeah, and this is actually my text editor based on Emacs, but Emacs works the same way, where it has functions you can define and bind keys to those functions and do stuff. It's a little harder in Emacs font handling. I gotta go. Have fun. Bye. Thank you, Angel, so much for coming. I really appreciate you being here. Shout out, Tina Angel. See you next time. Hey, can you browse the web? Yes. So Emacs has something called ew. And so you can enter a URL or keywords. So let's see Stack Overflow. Let's just see what happens. So you can see we're now contacting DuckDuckGo, and we are searching. There's some errors. It's fine. We can set show trailing white space to nil. That's better. So you can see this is DuckDuckGo. This is our search for Stack Overflow, and there's a picture here. So we can actually press enter, and now this is the Wikipedia for Stack Overflow that we are loading. I don't want to keep saying oh cool, but this is really interesting, my guy. Feel free to keep saying it. No one will stop you. So Emacs, for example, this is the Stack Overflow main page, right? And you can jump to search if you want to, and you could search here, enter stuff in the search box. So if you wanted to search Stack Overflow for like fread error, right? Then you can search and look. Oh, read, it's a system call. C file input output. Let's look at that. Oh, wow. Now we're looking at the C standard library. Let's look at fread. That's what we wanted, right? Okay, now we're on CPP reference. And here's fread. Hey, look, we have an example of how to use fread. But yeah, you can browse the web. It's totally doable. And it's just written in Lisp. It's that simple. And it does query your system, and if you have curl, it'll use curl. If you have wget, it'll use wget. I think it even uses like there's a way to open it in your actual browser while you're browsing in EU. So if you ever run into something like an image that won't load or a form you can't enter into, gonna have to put the brakes on Vim and have a good look at Emacs before committing to one. That's a great idea, my guy. You should always look at all your options before just diving into one, right? But from what I've heard, Vim can be configured in a very similar way. It's just using plugins instead of an entire like built-in. I know there is Vim script, but I don't actually see a lot of things written in Vim script. I feel like a lot of it is written in Lua, which is embedded in Vim. Which also, that's something we should do on stream one day. We should embed Lua in one of our programs. That'd be fun. Ooh, what if we embedded Lua into our compiler? And you could like have compile time Lua that runs. They both have strong community support, I'm guessing. Absolutely. So like if you basically, how I'm going to say this is companies that hire developers, they expect developers to use like any text editor they say to use, right? But most of the time they have what are called power users. And those power users, as they call them, can use the text editors that they prefer because they work better in them. So just by using Emacs and or Vim, you'll get called a power user at your job if you are a programmer. So I think that is kind of worth it in and of itself, just to be called a power user. Like, yeah, I'm a power user. I use Vim or Emacs. But yeah, there's actually here we can look at package list contents. Package list packages is what it is. And hopefully this didn't freeze. Yep, it didn't. Here, you can see all of the packages that are currently configured for me. These aren't installed, but these are actually, I could just click enter and go install them. That's the first thing I tell IT when I call them. Hi, power user here. Exactly. Oh, Prot actually got denote into GNU Elpa. Okay, that's actually awesome. If you don't know, you probably don't know because you're a Vim user. In the Emacs community, this guy Protosilaus, he's this Greek guy, and man, he does so much. Hey, Tree Mosher, thank you for the follow. If you would like, go down below, hit the Discord, and you'll get notifications every time I go live. I send announcements to this Discord server, and Twitch notifications aren't really working these days, so I use that. Just figured I'd let you know. Thank you so much for following. I really appreciate it. I just downloaded Vim at 11 p.m. last night. Oh, so you were at the start of your journey. I understand now. But yeah, these are all packages written for Emacs that you can just go download, and they all have uses and stuff. I don't use many of them, but there are a lot in here. Like there's already been 500 and we're at the letter C. There's over 5,000 packages that you can go download for Emacs. So I'd say the community is bumping, is how I would put it, but it's up to you. And you can see here's the packages I use, like Thick mode, really important. LSP mode I don't use, but I do have it. Maggot is the one reason to use Emacs, in my opinion. Like this, once I started learning how to use Maggot, it was insane. If you don't know, Maggot is a Git porcelain within Emacs. So this is actually this window here. This is Git. So here are my unstaged changes, untracked files. And this is actually equivalent to running, here, I gotta close. Did I close it? What just happened? Hello? Oh, it's here. It's equivalent to running git status, and it shows you this output in Emacs itself. And you can actually tab open and fold. What happens when you install all 5,000 packages? I assume that they wouldn't be compatible because those are from all different package repositories. But it would, in the worst case, it would be normal, right? Because Emacs has a lazy loading mechanism. So if you just use Emacs like normal and don't call any functions or don't do anything from those packages, you'll never actually load them. So life will just be as normal. But if you actually try to attempt to use 5,000 different packages, which would be difficult in and of itself, it would probably just crash or go very slow, like it does when you open very large files or files with long lines. Just like Vim. But yeah, Emacs has Git or Maggot built into it. So this is actually Git diffs. These are hunks. And you can discard individual hunks. So I could just get rid of this change, but not this one within an individual file. And you can also go within a hunk and say, oh, I want to stage just this. And then you could leave everything else behind and update that in your Git repo, but nothing else, if that makes sense. So, did we start parsing? We don't. So we're just gonna have to probably leave that for tomorrow or some other day when we work on this some more. Thank you so much, everybody, for watching. I really appreciate it. This source code is available on GitHub. You can check my link down below. It'll be my newest repository. I have that where have you been all my life feeling right now with these text editors, lol. Same. When I got into Emacs, it was like, oh my god, I can actually like configure it and change the colors and change how it looks and write my own syntax highlighting for my own languages. It's like, this is beautiful stuff. It's just extensible. You can do whatever you want. And of course, you're welcome for showing you all that. Anytime, my guy. I'll be streaming most of the time from 8 to 12 a.m. PST. But other than that, you'll get notifications in the Discord whenever I go live. Follow and you'll get notifications from Twitch when I go live. Thank you so much for watching. Check out the VOD if you didn't catch the whole stream. And thank you. See you around, boss. Thank you, Tree Mosher. Really appreciate it. Bye-bye, everybody. Bye, Mom. Bye, Dad.